All right, let's talk about a really clever piece of engineering that solves a problem you've probably seen a million times: the self-priming centrifugal pump. It sounds complicated, but it's a brilliant solution that makes a huge difference in so many industries.
So let's frame the problem. Picture this. You need to drain a ditch or an industrial sump. You obviously can't stick the pump down in all that gunk, so it has to sit up high on dry land. But here's the catch. A normal pump can't suck air to get started. So how in the world do you get that liquid all the way up to the pump? That's the exact puzzle these things are designed to solve.
So here's how we're going to break it all down. First, we'll dig into that core problem. Then we'll touch on the simple physics that makes it all work. After that, we'll reveal the secret ingredient that makes these pumps special, and I'll walk you through the priming cycle, step by step. We'll also look at the different kinds of pumps out there and wrap up with some key tips for putting them to work.
Okay, let's set the scene. In the real world of wastewater, construction sites, and pollution control, you're almost always dealing with, let's call it, dirty liquid. Water with mud, sand, and other stuff in it. Moving that liquid around reliably is a huge deal, and it's exactly where the need for this special kind of pump becomes absolutely critical.
And here's the heart of the problem. If you take a regular, run-of-the-mill centrifugal pump and you put it above the water level, what's known as a suction lift situation, it just won't work. It's not a flaw, it's just physics. It has to be full of liquid to even start, and it has no way to pull that liquid up to itself. It's a fundamental roadblock.
So to really get the solution, we've got to take a quick step back and understand the basic principle that powers all of these pumps in the first place, and that is, of course, centrifugal force. The best way to picture this is to think of a car tire spinning really fast on a wet road. What happens? It picks up water and flings it outwards, right? It throws it against the fender. The water doesn't get sucked in, it gets thrown out. That outward flinging motion, that's centrifugal force.
Okay, now let's apply that image directly to a pump. The spinning part inside the pump, the impeller, that's our car tire. And the pump's casing, or what's called the volute, that's the fender. Liquid comes into the very center, the eye of that spinning impeller, gets grabbed and is thrown outwards at high speed. The casing then catches it and directs it out the discharge pipe. It's a super effective system, but only if it's already full of liquid.
So, if a standard pump is a non-starter when there's air in the line, how does a self-priming pump pull off this trick? Well, the magic isn't actually magic at all. It comes down to two surprisingly simple but very clever additions to the basic design. And here they are. This is the secret sauce. You start with the same basic impeller and casing, but then you add two things. First, a built-in reservoir, kind of like a tank, right on the pump. This is the priming chamber. And second, you add a special internal channel that allows liquid to recirculate inside the pump. That's it. These two modifications completely change the game.
All right, now for the fun part. How did that little tank and that special channel actually work together to get rid of all the air and get the pump ready to go, all by itself? This is the priming cycle, and it's pretty ingenious.
Let's walk through this. So the very first time you use the pump, you fill up that chamber with liquid. When you turn it on, the impeller starts spinning that trapped liquid, which creates a low-pressure zone, a vacuum. This vacuum starts pulling air up from the suction pipe below. Now this is the cool part. That air gets mixed in with the liquid from the reservoir. This air-liquid mix gets flung into the discharge area, where the air, being lighter, separates and gets pushed out the discharge pipe. But the heavier liquid, it falls back down through that special recirculation channel to be used again. The pump just keeps repeating this cycle: mix, separate, purge, over and over, pulling more and more air out of the line, until finally that suction pipe is completely full of liquid. And boom, it starts pumping like a normal pump.
You see, without that trapped liquid and the recirculation port, a standard pump just gets what we call airbound. The impeller just spins around in the empty casing like a fan. It's moving air, sure, but it's not dense enough to create the vacuum it needs to actually lift the water. The pump is basically stuck.
Now that we get the how, it's worth knowing that not all self-priming pumps are the same. They're generally split into two main categories, and they're built for very different kinds of jobs.
So on one side, you have your basic self-priming pumps. These are the versatile, general-purpose guys, perfect for clear water or maybe water with a little bit of dirt in it. Then you have the heavy-duty, trash-handling pumps. These things are absolute workhorses. They're built for the really tough jobs. Think construction site dewatering with sticks, stones, and all sorts of solids. They even use a special kind of impeller designed specifically not to clog.
And one of the best things about these trash pumps is a super practical design feature, a big, removable cover plate right on the front. This means if a rock or some other debris does manage to jam up the impeller, you don't have to start disconnecting massive pipes. Nope, you just pop off that front cover, reach in, clear the clog, bolt it back on, and you are back in business in just a few minutes. It's so simple, but so effective.
All right, so you get how it works. You know which type you might need. Let's finish off with a few really important guidelines to make sure you're using these pumps the right way to get the best results.
Okay, here are the key takeaways. First, these pumps love low viscosity liquids. Think water, not something thick like molasses. Second, you want to keep that suction lift, the height it has to pull the water up, to a practical limit, say around 15 to 18 feet. It's also a really good idea to make your suction pipe the same size as the pump's inlet port. And finally, there's a more technical point about making sure you have enough pressure at the inlet to prevent issues. But the big picture is this: if you follow these rules, these pumps are absolutely perfect for any situation where you need to leave a pump running unattended, sitting high and dry.
And really, that quote sums it all up perfectly. Having a pump that can sit above the mess, prime itself automatically, and just run reliably without needing someone to babysit it, well, that's not just a nice feature. It's a seriously smart, cost-effective solution to a problem that pops up all over the place. It's a fantastic example of using simple physics in a really, really clever way.